So you have a resin printer, you can print all the cool custom plastic stuff you want, but you want metal stuff. Does that sound about right? I've made a bunch of videos on how you can use a 3D printer for sand casting or investment casting, but those take a lot of equipment. You need sand, obviously you need flasks or you need plaster, a big vacuum casting machine or a big expensive burnout oven, and there's a whole lot of steps. There is an easier way, and here it is. This is Monocure ThermaCAST resin. Monocure is the company that made the burnout resin without any wax. Burn Away it's called. ThermaCAST is not a burnout resin. This is a mold making, like a direct casting resin. Yeah, you print a mold in this stuff and you pour the metal straight into it. Think like die casting, but with resin printed dies. How does that work exactly? No idea. I assume witchcraft, but it's rated to handle up to 550 Celsius, which is about a little over 1,000 degrees Fahrenheit. 1,000 degrees Fahrenheit. And that's significant because alloys like pewter are very easy to cast. But here's a bar of pewter. It's not very strong. It looks really cool, and you can do some cool ornamental stuff with it, but functional stuff, not really. Maybe some things like belt buckles, here's one I did in pewter, but 1,000 Fahrenheit, 550 Celsius, means you can do like functional tough metals with it, like zinc alloys, like Zamic or ZA12, my favorite alloy of late. Sure, you can't do aluminum like other die casting, and you can't do bronze like the other kinds of casting, but Zamic alloys are not just decorative like pewter. They don't look as good as pewter, that's one, but they're very tough. I'm told Atlas lathe gears are made out of Zamic. Hot Wheels are made out of Zamic, and those are surprisingly tough. There are a lot of other mechanical bits made of Zamic, structural bits made of Zamic or other zinc alloys. Every day I'm fixing washing machines and they have a surprising amount of structural zinc alloys. My whole lathe that I'm building is made out of ZA12, which is a very durable zinc alloy that pours at well below 550 Celsius. Just to prove it can take the heat, I took some ZA12 and I poured it into a coin mold. I poured it into a coin mold that I made out of this ThermaCAST stuff and another identical one made out of a normal plastic resin. One of my favorite, I'm holding the mold right here. I think this is PAS 10, it's a Haygears resin. The detail's really good, the dimensional stability is really good, it doesn't warp over time. They do not say it can handle high temperatures at all. That is not what it's designed for. Just one pour and it's pretty toast. The regular resin is pretty toast. It looks, you could probably see it burned from here. I'll show you some close-ups. There's huge cracks, there's chunks coming out. When it cooled off, it did not conform back to the original shape. It's discolored, and it almost looks liquidy, like there's oils burning out of the thing. When I cast the same thing in a ThermaCAST mold, it looks fine afterwards. After some ZA12, which I poured much hotter, I might add, there's some fine cracks I can see, but there's no gaping holes. There's no liquid crud leaking out. The difference here is I poured the ThermaCAST one much hotter because I wanted more of the detail to come through, and I had already made a dozen coins using this mold. So a lot more use. It's definitely better at handling the high temperatures. The other resin is not designed for it, so shocker, it can't do it. The normal resin also smelled terrible when it was burning, and the off-gassing put bubbles in the coins. It's not a nice clean smooth surface. I also tried one in pewter, a lower temperature alloy, and it handled the pewter a little better, not well. You probably couldn't get more than a couple of coin casts out of it, but the same kind of bubbles and off-gassing still formed. So the castings are no good anyway. Okay, so I bet you want to know how to use this stuff, right? They sent me this giant jug, and I burned through basically all of it, coming up with a list of tips for you. So I'm going to walk you through all of that, and I'm going to do it in the order that you would make something. So first up, mold design. Shrinkage, flow, all that stuff that I've talked about with other types of casting, it still applies. I'll show you a close-up of the back of one of these, the coins that I just showed you, and you can see kind of a dark, nasty-looking line right below the sprue. And that's for the same reason you get it in all the other kinds of casting. So it's turbulent metal mixing up oxides and junk. There's no sand in this, which is handy, but air entrainment and just oxides getting stirred up, that can still happen. I didn't bother dealing with that in this mold or any of them that I made for this video because I was just playing around with it. And if I come up with something that I really want to look perfect, I'll deal with it then. But that comes in the 3D modeling stage. And then thickness is a thing. This is the backer of the coin mold. This is what I did all the ZA12 pours in. This is about 10 mil thick, about a centimeter. They say go at least 8 mil for ZA12. I'd say round that up to a 10. Here's a thinner one. This is like 4 or 5, so this is what they would recommend for pewter. I've done a whole bunch of pewter castings with this. I wouldn't go any thinner than 5 because they say it, but I've poured a bunch of stuff in this mold. I can't even tell. It still looks new. ZA12, that's a lot hotter. The thickness doesn't just give you like more meat to handle the temperature. When the surface heats up from the metal hitting it, the resin will want to expand, and all this extra chunk will actually hold it in place and resist that warping a little bit more. So just something to keep in mind. Now, if you're doing a multi-part mold, kind of like this one, this was a 3-part mold for a drawer pull. I've made a few of these. One says drawer pull, in case you forgot what it was. This one says pull, in case you forgot how drawer pulls work. And I got another one here that says no, no. Just in case you have a drawer that you don't want people to open. I don't have a drawer like that, but because I can make these now, you can bet I'm gonna make a drawer like that. I don't know, I'll fill it with like a million snakes. Spring snakes, those are fun. Anyways, clearance is important. So the 2 halves of this, there's 2 identical mirror pieces of this. They fit together nice and tight. And then there's kind of a bottom plug. And these are all the different things where I can get the different designs. So all the shells are the same. I only printed one of these, well, 1 pair. And then I printed a few different ones of these so I can stick them in the bottom. So when I pour, I get the fancy thing. There's a hole in the top for the screw. That way I pour around a screw, unthread the screw. Now I have a threaded hole, right? Instant drawer pull, no need to tap it. These are designed to fit tight, and then I printed them a few percent smaller because when they go together, they're gonna be a little bit too tight, right? And with printed stuff, you wanna leave like, I usually say like 0.2 of a millimeter is a fair amount. You wanna go small enough that it will fit together without binding and you can actually clamp everything together, but not too small that it leaves a gap large enough for metal to flow through. What that is exactly, I'm not certain, but 0.2 of a millimeter seemed to work. Try that. You can actually plug up holes with aluminum foil tape. So if you put all this together and you see a little gap, wrap it in aluminum foil tape, that seems to work. You also want to allow areas for clamps to happen like this. This is just a big chunky thing, but this is a belt buckle mold, and I have kind of these large flat areas around, and you can put clamps on there. This was printed too small, and I clamped the bejesus out of it on accident, not adjusting my clamp, and you can break it. So be careful with that. Here's another example. This is a top mold for making a cool little top. I didn't design this. A friend of mine named Nathan designed it. I'll put a link to his channel in the description. I chopped out a bunch of the mold size to try to save on resin. It's kind of stupid, don't bother. It'll just make the mold more difficult to use and it won't last as long. So all of it's wasted. But this has 2 large flat sections for me to clamp. So I can put on these big, thick, chunky sections, clamps to hold it together. You might notice on the drawer pull one, there's a flat section here. That's for a clamp to go on. It really needs to be bigger than this. Don't try to save a ton of this resin on each individual mold. You'll end up wrecking the mold more quickly, and then you'll have to print another one anyway. Just make them chunky enough. Then, like in sand casting, draft is a consideration. That means there can't be any undercuts. The best way to think about that is, can you take the mold, fill it full of metal, and pull the metal out without breaking chunks off the mold? If yes, you probably have draft. If you have undercuts, that will catch, and you'll have to break the mold to get the thing out. Now you can do shell molds, like a ceramic shell, but with like a resin shell. You'll just have to break the resin off to get the thing out. Here's one example of that. I stole this idea from Nathan too. This isn't his design, but I stole it, totally stole it from him. This is a little holder. It holds these little balls. The ball is hollow. Inside the ball is the hollow area of a die. You put that in here, you pour in there. You can get these apart, but if you want the die out of there, you gotta break it out because there's no draft. There's no way to get it apart. Okay, slicing. Arranging the part in the slicer is a little bit different. This is where it's different. I have found if you have a surface, a flat surface that has to clamp against something else, like in the case of these or these, it's more important on a larger thing. You want that surface to be one layer, which means that surface should be parallel to the build plate. I know generally they want you to like angle stuff. The more I angled stuff, the more print failures I had and the more warped things I had. If the thing warps, it won't seal. I don't think this warps any more than any other normal resin, but the thing is, these have to fit together clean and nice. If there's a gap, all the metal pours out. So the stakes are kind of higher for a warped piece. I printed these on 2 printers that had, one of them had the peeling, this is a Mars with the peeling plate. The other was a GK3 Ultra. My GK3 Ultra has an ACF film. It doesn't have the normal FEP sheet. ACF lets go of the stuff easier. In the vat, it can settle a little bit more quickly than most other resins. It isn't worse than some other resins, but it's definitely not the best. Always stir it before you start. You don't need a special printer for this. You can use a Mars 3. If that's all you got, this will work. Cleaning is a little more involved also. It's just IPA, isopropyl alcohol, just like everything else. This resin can be kind of sticky, especially when you have little details like in these like game piece molds. I find, put on your nitrile gloves, grab an old toothbrush, dunk it in the alcohol and do a little bit of scrubbing. Then other than that, it cleans pretty normal. The only issue you might have is cleaning inside these shell molds. I can't get a toothbrush in there. And I was stupid enough to print these with some supports inside there, and I probably shouldn't have, because I couldn't get all the supports out of there. So when I cast a die in this, I ended up with what looked like porosity, but on closer inspection was actually chunks of resin that I didn't clean out. Curing, also slightly different. This stuff is thick, especially if you print them thick, like I always do now. Cure it for an hour, at least an hour. Just a standard curing station will work, but leave it in there an hour, a good hour. Okay, now you're gonna cast it. What metal are you going to use? Well, you can use anything below 550 Celsius. I have a bunch of examples here of some metals. This is a pewter alloy. This is a different pewter alloy. This was a third pewter alloy. I did a lot of pewter, and I didn't label which of these was which. I just did a lot of metals. And some of these, I think these coins, were in a very low melting alloy. So pewter is mainly tin. This has a lot of bismuth in it, and it melts at a much lower temperature. Some of these bismuth alloys melt at 202 Fahrenheit. It's less than boiling water. Some of them melt like 230, 350. And where can you get these? Easy, you can get them at Rotometals. Same place I get my ZA12 from. Speaking of ZA12, you can use that too, and any Zamic alloy. I use ZA12 specifically because it comes in these ingots that fit in the electric furnace. I'll put a link to Rotometals down below. They are awesome. You can buy individual ingots, which is great, and these small sizes if you want. It's very handy. They just ship right to your door. I think they ship internationally too. Bismuth alloys expand when they freeze, so you don't get shrinkage when it cools. You get, it can actually push itself into the little details a little better. But if you use the really low stuff, the 202 melting alloy, it's a hypereutectic alloy, which means the metals, it's like a super saturation. They'll want us come out when they're freezing. This is nerdy, I'm sorry, but it gives you a really cool hammered metal texture. I'll put a close up here. I did a gingery lathe knob in it. It looks super cool. Well, moving on. So because this metal melts at such a low temperature, you can use one of those electric furnaces. You know, the 3 kilogram crucible is large enough to just take one of these ingots and slide it down in there. But you don't even need to use that. You can just use a graphite ingot tray like this, which I put in a clamp, and I just hit it with a plumber's torch, and the stuff melts like it's water. It's very easy. You can just blast it in here and then pour it in the top. You can get these at a hardware store. You can get these on Amazon. The clamps are like $3 at Home Depot or something. Or if you want to melt a bunch of it, use the electric one. Now sometimes the metal will want to stick, especially if you have details like letters. They recommend using a parting powder like talc, just dusting it with talc. I didn't bother. I used a lot of draft. 5 or 10% draft, everything just came right out. One thing I will say, make sure to clamp thoroughly. Clamp thoroughly enough to prevent leaks. When I cast this is one of those grills for my face mask. I made like a bunch of these. This was just something that I was doing. This part, these molds, I didn't know really how to print this stuff properly at the time, especially about orientation. And I ended up with some printing issues here. Again, not the resin, this is the printer. I was using a very worn out Mars 5 Ultra for this. And there's some gaps. But because I have these large flap areas around, I just carpeted the thing with clamps and poured the metal in. And as you can see, it didn't leak out. I did get a hole in exactly the same place as the SandCAST one though. There might be an issue with that 3D model. The cool thing is because pewter melts at such a low temperature, and this stuff is so good at handling the heat, this mold still looks like new. I can cast more of them. This stuff does not vent, so the air needs somewhere to go. Here are some vents. You can see them here in the molds. That's where air can escape. There's also one down below. You can kind of see them showing up here in the mold. Also, if you don't clamp them super tight, you will get air kind of escaping between the two pieces, although you will get a lot of flashing. This is supposed to have, these are all supposed to be open holes. That's easy enough to clean up with a Dremel afterwards though. Here's one that I clamped a little harder, seemed to work a little better. Still needs to clean up all the flashing. Casting this on top of a vibrating tray can help. I don't have one of those, so I just kind of bang the mold against the table. That may not work as well. I mean, it doesn't work super great. And you will end up with air bubbles trapped. Like you can kind of see here in this belt buckle. All of these like hollowed in areas, those are air bubbles. This was an expanding alloy, not a shrinkage alloy. So those are air bubbles that are trapped. And that's it. You have poured the metal, let it solidify, remove it. If you're gonna pour another one, let the mold cool off. If you're using like that Roto, like the 202 or the 230, whatever Fahrenheit bismuth alloy, you can probably just pour them back to back. That's not gonna be an issue. I didn't have a problem and I cast a whole bunch of stuff with that. If you're using pewter, give it a minute. Give it a couple minutes. If you're using ZA12, let the stuff cool off. Just know if you're using the same mold for ZA12, back to back to back to back to back, even if you let it cool down, you're not gonna get infinite number of castings out of it. You'll get a few and it'll start getting damaged. If you're using the 202 stuff, go nuts. And I do mean you can make several. I made a bunch of these game token coin things. I made this stack of game tokens, metal game tokens, and painted them. This is for a Korean New Year's game that we played. And I can cast a lot more of these. I only printed one of these molds ever. It still looks good as new. So I can just manufacture these really if I want. I forget what metal these are in. I think these are just pewter. Here's a little drum pendant that I made for my daughter. My oldest daughter is a drummer. Tulip things made for my wife. A little necklace thing that she can wear. Valentine's Day is coming up. And really, sky's the limit. And then it's just sand and polish, just like any other metal thing, because that's what it is. And that's just the beginning of this stuff. Now it's on sale, so I can buy more. Let me know down below what you would use this for. If you want to see me do anything specific, put it in the comments. I think you might have an idea what I'm going to do with it a bit more. I believe if you buy it soon after this video publishes, when most of you will watch this, they might have free shipping to the USA. Click a link down below, you'll see it. Otherwise, they plan on putting it in the Amazon store pretty soon. Let me know what you think of this resin down below. I think it's pretty awesome. It's probably the coolest resin that I've tried so far. And if you want to see other ways to use a 3D printer to make solid metal castings, there's a link on the screen.